Alright everybody, I've actually made an iPhone app. It's a very basic kind of generic blackjack card counter. I'm going to show three different videos on this and how I came to a final product. It involves just some playing around, a little bit of borrowing code, a little bit of developing code, a little bit of simulation, and I actually hired a UI developer at the end, and I'm going to go over that in the last video on how I did that, what was the outcome like, and I'm actually going to share his profile as well. So this is going to start with where I found my original blackjack game in order to try out my code. So the initial code was actually at askpython.com/python/examples/blackjack game using Python. So if you come here, it walks you through a how-to manual. It's based off of Linux, which you can see here, but it works just fine. I use Jupyter Notebook, and here's the actual printing that it will do in the terminal. So what this looks like is it's actually, I'm going to go cell by cell here, but it's a blackjack game that you play in the terminal of your Python console. So the very first line here, you're just going to import a couple libraries. The first being random. The random library is going to be used to grab different cards from the deck. So it's basically going to take random cards out of the deck that you'll create later on. You're going to import the operating system or OS library. What this is going to allow you to do is just to clear the terminal essentially. And in the original code, it also had importing the time module. You don't actually need this, so I don't know why that was there. It may have just been something they had put in as they were building it and eventually removed whatever they were working with. So I'll go ahead and run that line. The next cell here is going to be developing the card class. So you're going to initialize it with the self input, which is kind of a general setting whenever you're developing a class. You will have suits, values, and card values. So the suit is going to be a suit like spades, diamonds, hearts, clubs, things like that. That's actually going to be used down the way. It's really not important, as far as I'm aware, in counting any cards. But it's going to be used to actually print out the suit itself in the terminal. So they actually steal some shapes and things. Then you're going to have value, which the value will represent a card like A for ace or K for king. But then you also have card value. So where K for king is the value of the card value will represent 10 for king. So that's the numerical value. So we're going to call that eventually. But the next thing we're going to do, let me go ahead and run that line. So the next thing you're going to do is just clear the terminal. So if you do have anything in it, you're going to be printing in the terminal here, so it's going to get rid of everything for you there. And actually the system may actually clear more than just the terminal. So if it does more than that, disregard what I said. And then here there's going to be a function or to actually print the cards. So hidden just represents whether or not there's a card that's hidden from view. So you'll see the back of the card. And all this is showing here is these lines, and the \T represents tabs, so it's just a spacing. That's going to be like the base of the card or the side of the card. So in this case, it's the side of the card with a lot of empty space in between, and it's going to print numerous lines of that. And then here it's going to print the top of the card. Wherever you see this hidden, you're going to be embedding the card value. And remember, value, if we go up, represents the A or the K for the king, or it would be the card value if it's a normal card. And then again, if it's hidden, it's going to print just the empty space during that. So this entire module is just here to print the various values there. So we'll go all the way to the bottom, and I'll go ahead and run that. And then comes the bulk or the meat of the actual game. So again, this code that you're looking at, this was just taken from that initial website. This is not what the app was based on. This just allows the card counter to run and check whether or not it's working. So I had to find a blackjack game, essentially, that I could embed into, and this was simple enough. So here you're going to have the blackjack game, and it's going to take the deck that you will create eventually as the input. it initializes the player's card is empty and the dealer cards is empty, and your initial scores are also set to 0. While the player's cards are less than 2, you're going to have a random draw from the deck, and you're going to append that card to your player cards. And from the deck, you need to make sure that you remove the player card. Then you need to update the score. So this plus equal sign just takes whatever the initial score was, which if you look up top here was 0, and will add the card value to that score. If this is kind of one of the trickier parts of developing a blackjack game, if you pull an ace, ace can have two values, a 1 or an 11, and it's dependent upon what your total value is. So here it's checking to see if you have two cards. If both of those cards have a value of 11, that would equal a total value of 22, which with blackjack your goal is to hit 21 or as close to 21 without going over 21. And so 11 plus 11 would equal 22. And in that case, of course, you would be over 21. So it will set the initial card value back down to 1, which is the alternative for the ace card. It was either 1 or 11, and it will decrease this player's score by 10. So it kind of auto-corrects if you happen to draw two aces initially. Then it's going to print the cards, and it's going to take an input. And the input we'll see here in a little bit. Then you're going to go ahead and do the same for the dealer. So the dealer is going to go ahead and draw his card. You're going to update the score on that. It's going to print the dealer score as well, and it goes through this list. And again, it does the same correction in case there are two aces. It weighs the score, so it checks to see if the player has the 21. If it does, the player has a blackjack and the player wins. Great job. And it does the same here for the dealer. Excuse me. They won't do that for the dealer just yet because the dealer is only set to one card. The player then has the option to hit or stand. Hit just means you take another card, and it adds that value to your score. And S would be for stand. It means that you don't do anything, and you're risking that the dealer will hopefully bust. So here it checks your score, and this is a really handy option to use is choice.upper. What upper does is allow for any input, it will automatically uppercase it or capitalize it to, if you have a lowercase h, it'll put it to a uppercase h. What that enables you to do is regardless of if the user inputs a lowercase or uppercase, it will compare them the same. So if it's not an H for hit or an S for stand, it says wrong choice, and it allows the user to try again. If it is a hit, then the game will draw another card for the player, again using that random dot choice from the deck, and it will append that card to the player cards. Again, don't forget it needs to remove that card from the deck. So then it updates the score, and it checks to see what the score is. So as it goes through again, it's going to correct for any aces here. So if there happens to be a card value of 11 and the score happens to be over 21, it's going to correct for that, drop the score down to a 1, or sorry, the card value down to a 1 rather than 11, and decrease the points by 10. And then it moves to the next card. Then it goes into the dealer cards and does the same thing, and again it gives the choice of whether or not to hit or stand. So it runs through this several times until either the player has blackjack or one or two, either the player or the dealer busts. So I'm going to go ahead and run this line, and then here it's going to run the actual code. When it calls the actual function, it needs inputs. If we drag back up to the very top here, let's see, we need a suit, we need a value, and we need a card value. So if I come all the way back down here, we have our suits, which are going to be the general suits of the deck. It's going to be spades, hearts, clubs, diamonds. Suits values is going to be spades. And what's handy about this is this little acronym here is a string code. I think it's Unicode, if I'm not mistaken. I'm probably wrong on that. But it actually represents the symbol for spades and the symbol for hearts and the symbol for clubs and the symbol for diamonds. What's handy about that is when you go to the print function, when it prints the player cards up here, it's going to the card value there, and it's also going to do the, where is it, the suits, I believe. There it is, card suit. And it's going to print the suit as part of the graphic in the terminal, which is kind of neat. So here we are. We're going to go back down to here, and then we have the card values. It automatically sets the ace 2 and 11, which is why we accommodated for that correction previously, dropping the 11 to a 1 if the player or dealer goes above 21. The deck of cards is originated as 0, or it's empty, excuse me. And for as it loops through, it goes through every suit and every card, and it appends those to the deck. So it builds your deck that way. So as I hit this, you'll see it prints out my card, and notice we have that initial line up here, and then those side lines as we go with our card value, the suit, and the card value. When you go back up to the print, that's what you were seeing all through here. So all these side values were on the side of the card. These top values were the top of the card. Here we printed the suit. Here we printed the card value, etc. So as we come back down here, it is asking me, it has my player score is set to a 10. So I'm just going to go ahead and I'm going to hit an H for hit, and I think I just had to hit enter there. And then it has the dealer card set to 2. So the player's at 10, dealer's at 2. I should hit. So I'm going to go ahead and hit that. And it went ahead and gave me a 6, so I'm at 16 now. So the question is, should I hit? I have 5 cards to get me, or a value of 5 to get me to 21, and there's 4 suits of cards between that. One of those is taken. So I have 5 times 4, that's 20 total cards minus 1, 19 cards out of 52 total. I'm going to go ahead and stay. So here, dealer is going to have an unknown. Let's see, player score is 16, dealer score is still 2. Do I want to hit or stand? I'm going to stand. Dealer score, they go up to 5. Go ahead and hit enter. Dealer score is just 16. Oh goodness. Dealer score is 21. So he went ahead and beat me here. Blackjack, player loses. And here the kernel died. So there's definitely not the smoothest kernel here, but it gives you the idea, and it'll restart automatically. So this is the starting point to building this app. I just needed something that would allow me to test a card counter as I played. And so I found this kind of rudimentary but very nice blackjack game. And again, that was found at this askpython.com/python/examples. And there's a blackjack game using Python. Anyway, I hope that was helpful. I will have the final app link in the description. And I'm also going to have a link to the gentleman that I used through Upwork, who actually helped me with the user interface and everything and did a great job. So if you ever have any projects, I definitely would recommend him. So I'll have those 2 links at the bottom, and I'll have 2 more videos on this, at least 2 more videos on this, all the way through the final project.